defined it, but that's a different problem. Test 7, number 5. God in Himmel, how hard is it to find? There, I found it. No, that's not it. I'll look at yours, Rachel. That way it's the same numbers. Maybe the best way to do this. Rachel. Last name again, Bell?
Yes.
Okay, I'm getting, only took 10 weeks to remember your last name. Okay, so question number 7 coming up. Oh, yes, I remember. This is the related rate one. So what we have
question,
is...
question 5.
Oh, 5.
Yeah.
Okay. 7 is the walking along the floor one. All right. So question 5 is different. You're told that 4x squared plus 16y squared equals 100, and the x and y are both variables. You're also told in question A that dy by dt is a quarter. And you're being asked to find the derivative dx by dt, and you have to do it when x is 3 and y is 2. Okay, we've got the whole package. So we're going to take this equation and we're going to differentiate it with respect to t. So 4x squared gets you 8x times dx by dt, and 16y squared is going to get me 32y times dy by dt. And the number 100, because it's a number, when you differentiate with respect to t, you get 0. So you differentiate with respect to t each of these. And isn't that a little bit like implicit differentiation, right? You know, so with respect to t, you get 8, right? 8x, and then you finish with a dx by dt, 32y, dy by dt. Now we should be able to plug in all the numbers. I know that dy by dt is a quarter. I know y is 2, so that's 32 times 2 times a quarter. I have 8, I know x is 3, and being asked to find dx by dt. So essentially, when you plug in all the numbers, either from here or here, there's only one thing missing, and that's what we're being asked to find, that guy. So I have 24 times 3 dx by dt, and that guy times that gets me, I believe, 16. And I'm really just going to solve an equation here. So I'm going to subtract 16 from both sides. And then I'm going to divide both sides by 24. And I can divide both of these by 8. And the final answer then is -2/3. So what that is telling me is that in this shape, if the x's are increasing at this rate, at the point when x is 3 and y is 2, then, sorry, the y's are decreasing at this rate, then the x's are going to decrease at that rate. So one of them's getting bigger, but the other is, so that basically is an ellipse. So the ellipse is growing this way, but it's shrinking downwards as well at the same time. And the shrinking is negative, right? It's going smaller than one of the axes. Do you need to see the second one? Is that also a problem?
No, I just remember I lost a lot of time because the wording was kind of different. And so, and I wasn't sure if it was a differential or how to approach it. So, but okay. Now I see.
Right. The key that makes this different from implicit. So let me put both side by side without too much details. Both questions superficially will look identical. The main difference is, and the way you can tell the difference between the two methods is that in one of them, you're going to be finding a derivative with respect to a guy called t, whereas in the other, you're going to be finding dy by dx. And so when you get this one, we call this implicit differentiation. And this is a related rate. So if you wanted to differentiate this to find dy by dx, then it's not quite the same as this working, right? You differentiate this with respect to x, you just get ax, right? There's nothing else added. If you differentiate this fella, you get 32y times dy by dx. And then you get 100. You see the difference in the working compared to what that one looks like? You see each one of them, the x and the y are treated essentially the same. But in this one, aren't the x's treated like x's, but the y's are treated differently. Now, at this point, just because I've started, I guess I should finish, you solve for dy by dx. So I'm going to subtract ax from both sides. I'm going to divide both sides by, in this case, 32y. And I can divide them by 8. If you divide them by 8, you get that. So when you do implicit differentiation, your answer will be dy by dx equals some function of x's and y's. But when you do one of these guys, the dx by dt will be a number. You see, the answer even looks different from each other. So they are distinctly different things, but you should be able to tell by what you're being asked to find. So for one last time, if they're asking you to find dy by dx, it's implicit, do it this way. If they're asking you to find dx by dt or dy by dt, that's typically what they're asking you, right? It's this guy, related rates. Next question.
I had a question about the test yesterday.
Sure.
Could we
that?
go over one of the antiderivatives, like with the restraints or the boundary things?
Oh, with boundary conditions. Gotcha, right? So do you want me to do the specific question or just make up one like it? How do you want me to do it for this?
Just one like it, yeah.
Okay, so let's suppose then that we have the derivative of a function and it's 3 cosine x, take away 2x cubed plus 10 over x, right? And you're being told that f of 1 equals 10. Now, this guy here, right, sometimes called an initial condition, also sometimes called a boundary condition. This guy here, this piece of information, has one job. It allows you to find out what c is. So I'm going to do an antiderivative. So in this notation, the antiderivative of that is f of x. If you find the antiderivative of cosine, what's the antiderivative of a cosine? Anybody got it in their head? Antiderivative of a cosine.
A sine?
It's a sine. So 3 cosine gets you 3 sines. And here's how you check. Most people are really good at differentiation, right? Because we've done a lot more of it. If you differentiate 3 sine x, don't you get 3 cosine x? Agreed? That means you've done it right. Now, when you get these guys, we do a thing called the power rule as well. You add 1 to the power and then you divide by the new power. Are you comfortable about why it's negative a half x to the 4? Right, and this one is a special case. This is one of these that you just memorize, just like you memorize this one. What is the antiderivative of that weird fraction 10 over x? 10 over x, what does that guy get you?
10 ln x.
Yeah, gets you the natural log of x. And you always finish with what's called the arbitrary constant, right? A plus c. That's what you finish with. So far, so good. Now, let's bring this into play. F of 1 is 3 times the sine of 1. Take away 1/2 1 to the power of 4 plus the natural log of 1, add c, and this is going to equal 10, right? Because f of 1 equals 10. Not very nice, but it is what it is. The natural log of 1 is 0, so I have that. Now, if you subtract 3 times the sine of 1 from both sides and you add 1/2, c ends up being, well, technically 10.5, but we call that 21/2. Not the prettiest answer in the world, but that's because I just made that up on the spur of the moment, but that is c. So your final answer is f of x is 3 sine x, take away 1/2 x to the 4 plus log x plus c, and plus c becomes all of this. Are you good with that? Do you want to see a second derivative version of that? Where
Mm,
you-
I
What? Hmm?
wasn't there one where it like the boundaries were like x is greater than or equal to like that.
Oh, yeah, in this question, you might well get that written down, right? You're talking about sometimes they have this written down at the end.
Yeah.
That has no effect on the answer. That's just to make it legal. What do you mean by that? Can you imagine I had a question, a very simple one, which is, let's find the antiderivative of the square root of x. Do you know that they would put it beside this?
Okay.
And the only reason that's there is, shouldn't you never use a square root with a negative number in it because they don't exist? So those things are there to keep everything kosher, right? Mathematically correct, but they don't have any effect on what you do, right? So you were maybe paying too much attention to that and letting it distract you. On the other hand, this is important because doesn't this allow you to find the missing c? That's not important. This is here because log functions aren't allowed to use negative numbers either.
I have a question about that log function.
Mm-hmm.
So when you're finding the antiderivative of anything over x, does it
Mhm.
always end up as just ln over x, or would that be 10 ln over, or?
It depends what the top number is, really, right? So if it was 1 over x, the antiderivative would be that guy. If it was 10 over x, like it is here, it would be that guy. And if it was minus, I don't know, 13 over x, it would be that guy.
Oh, so it's the
X on the bottom that makes the
Antiderivative.
log happen.
Okay, so then in this question,
That's why this is 10. Oh, darn it in
It-
space.
okay,
Thankfully, it made no difference to that part of the answer, but it did make a difference to there. Yeah,
okay.
I was just
Thank you
me
so
being
much.
careless. I think I wrote 10, but I saw 1. You know, when I was looking up, I just misinterpreted it. But the fact you noticed, yeah. Rachel,
Is the x must be positive because they already know that there's going to be a natural log in the
yeah,
answer.
they're predicting it before you even see it. Next question. That was a good one. Or a topic, just a general thing. You know, can we go over insert
someone
topic here?
commented a question.
Oh, I can't see those. What was it about? Can you read
It says, I have a question about homework 4.9, question 25.
Okay, let's do that then. 4.925. Where are you? 4.9. Okay. Oh, I had it in front of me and then I closed it. Never mind. Okay, that's Oh, the last one. That should be a fun one. Oh, yeah. You're being told the acceleration is that guy. And you're also being told that S of 0 is equal to 0. And S is, that's the position function, at 1 equals 20. So these are the boundary conditions. And this one's a little bit sneaky because they're telling you both boundary conditions are to do with the position function. So that's going to make it a little bit trickier. If you find the antiderivative of acceleration, you get velocity and power rule. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. 8 gets you 8t plus c. But none of them are any use because this is a velocity. If they had a v of 0 equals 20 or a v of 0 equals 0, then I could have used it, right? But I don't have anything with v here, so all I can do is move on. So the antiderivative of a velocity gets you what we call the position function, s of t. And add 1 to the power and divide by the new power. Add 1 to the power and divide by that new power. Add 1 to the power and divide by new power. And then you have to figure out what happens to this c when you find its antiderivative. Now think of c as a constant. That means it's a number. What would the antiderivative of a number be? What would I write here?
CX.
Okay. Or in this case, ct. But I know what you meant. And you still need yet another arbitrary constant. This time I'll call it p. So here is what we're after, the position function, but it contains two unknowns, an unknown constant c and an unknown constant d. So I'm going to take my boundary conditions and start using them. I'm going to call this one number 1. So they told me that s of 0 is 0. So s of 0 is 1/12 of 0 to the 4, which is 0. Take away 760 cubed, which is 0. Add 4 0 squared, which is 0. Plus c times 0 is 0 plus d. So that's what s of 0 is equal to. A whole load of zeros plus d, and it's equal to 0. And so, well, that was pretty easy. That makes d has to be 0 for that to be true. So I now know a little bit more. My position function is 1/12 t to the 4, take away 7/6 cubed, plus 4t squared, plus ct, plus nothing, but nobody writes plus nothing down. I'm now going to use boundary condition number 2. And they said s of 1 equals 20. So let's see what that looks like. S of 1 is 1/12 times 1 to the 4. Take away 7/6 times 1 cubed, plus 4 times 1 squared, plus c times 1. And that has to equal 20. So this guy is a 12. Take away 7/6. Add 4. Add 1 times c is c equals 20. Can you see where this is going? Can you see what I should be able to do now is in a little while? Shouldn't I be able to find out what number c is? Right? All of this plus c is 20. Since I'm lazy, I am going to take 20, subtract a 12 from both sides, add a 7/6 to both sides, and take away a 4 from both sides. And that's what c would equal. And the reason I'm doing that is just to make it a little bit quicker on my calculator. So 20, take away a 12, add a 7/6, take away a 4, and then make it a fraction. And the answer is 205/12. So our final position function 1/12 t to the 4, should use here, 76t cubed, 4t squared plus c times t. So it's going to be plus 205/12 t. We're finished. That's kind of connected to yours, Vanessa, isn't that like the next step up where you have to do it twice, and each time you do it, you add another average constant. But eventually you will be told information, the boundary conditions, in this case these, that will allow you to find the guys you're after. Okay, whoever that was, I hope I've answered your question.
That was my question too, and that answered that for me.
Perfect. That's the advantage of people doing questions that they have some trouble with, is there are always 2 or 3 other people saying, yeah, I had problems with that as well. So you're helping everybody, not just yourself. Okay, where are we off to next, guys?
Could we go over question 10 on homework 3.9?
3.9, number 10, coming up. Close this window. That's not what I wanted. Oh, it's another related rate. Okay. And question 10. What's the street light one? Okay. And so I'm drawing a little picture of this. Visually, it very often helps me. A street light is mounted at the top of a 15-foot pole. So there we go. You've just told me that that distance there is 15 feet. That's my street light. A man is 6 feet tall. So we'll have the man here. And you have just told me that he's 6 feet tall. Okay, we got that. And he's walking away from the pole at 7 feet per second. So you're going to take this guy and he's walking away, and I'm going to call that X because I want to. And he's walking away at the speed, so that's dx by dt is 7 feet per second. Okay. How fast is the tip of the shadow? Okay, so let's put in where the tip of the shadow would be. Right, how far is the tip of the shadow, which is that distance from here to here? Which I guess I'm going to call y, right? So you're being asked to find how fast is the tip of the shadow, so dy by dt, at what point in time? When he is 30 feet from the pole, right? So when that's 30, so when y is equal to 30, right? So that's all the information that we've got, right? 15 feet, 6 feet, this is dx by dt is 7, this is the guy y. We're ready to rock and roll here. So what I'm going to have to do here is get a formula that's connecting the x's and the y's together. And the way I'm going to do this is by using what's called similar triangles. I know this is 15. I know this total distance is y. And I have a little baby one, which is 6 and x. And these two triangles are the same shape but different sizes. That's called similar triangles when that happens. And when triangles are similar in shape, corresponding sides are in equal ratio. So that 15 divided by 6 will be the same number as this y divided by x. Now, if I just do a little cross multiply here, I get 6y is 15x. And that means y is going to be 15 over 6x. I can divide both things by 3, so y equals 5 upon 2x.
Didn't we know that y equals 30?
Yeah, but that's just a snapshot. So you don't use that yet because we're wanting to know what this is at that particular value of y, but at y equals 20, that'll be something in y equals 40. So that will get used, but not yet. It might actually not get used at all, which is very rare. You must find this guy first. That'll come later. Now, once you have a connecting function, you then do the differentiation with respect to t. So if you differentiate this guy with respect to t, you get that. And this guy, you get that. And in this particular question, the guy that we're being asked to find is just 5 halves times this guy. So it's 5 halves times 7. And so it's 35 over 2. Did I do 2 right? Let's check that. 3. Yeah, okay. Which means that the tip of the shadow doesn't care how far y is. It's going at the same speed all the time. That's a little bit usual. Now, when would that 30 be used? Can you imagine I differentiated this and we had a little bit more information? Like this ended up having x's and y's in it. That could happen. Then I would have to factor in whatever y is, and if I needed to, I'd find x and plug that in. But in this very special question, the connecting formula generated a derivative that didn't care about x and y. It really just cares what this is. A little bit unusual. Are you good?
Yep.
Okay. A lot of these related rate questions are kind of individual. I mean, I think there's 2 walking away from the poll questions, or if not 2, there's only 1. So you're not going to get, your job is not to memorize or to figure out how you do a shadow walking away from a poll question, because that's not going to help you unless you get really lucky and that appeared in the test. You have to try and learn the process of what you do. So you get a connecting formula, right? Some formula that connects the x's and the y's, and sometimes x's, y's, and z's. I've seen questions where there were 3 variables, right? Once you've got a connecting formula, differentiate with respect to t, then plug in all the numbers, and there'll only be one guy you don't know, and that's the guy you're going to be solving for. That's essentially how the process works. Are we good?
So would you use the same process with on that test number 7? Problem number 7?
Yeah, I would use it with problem number 7. Problem number 7 is, again, in related rates, is saying that x squared plus y squared plus z squared equals 9. And they tell you that dx by dt is, in my question, 4. They also tell you that dy by dt is 5. And you're being asked to find dz by dt. That's typically what you've been asked to find. And you have to do it at a single point. At that point. Right, so we already have the connecting question, right? An equation that has x's, y's, and z's in it. So that's great. I don't need to get one. I got one. Okay. So what I'm going to do now is differentiate with respect to x. So 2x dx by dt plus 2y dy by dt plus 2z dz by dt. And if you differentiate a number, you get 0. Now I know x, y, and z values from here. So that's 2 times 2. I know dx by dt is 4. I know 2 times y times dy by dt, which is 5, plus 2 times z, which is 1, dz by dt, and it's still equal to 0. Do you see what we've got now is basically an equation that will allow me to get dz by dt. So 2, 4, and 4 makes 16. 2, 4, and 5 makes 20, plus 2 lots of those guys. And it's still equal to 0. So to save a line of working, if you add these, it's 36. If you then take away 36 from both sides, and if you've got dz by dt, then divide both sides by 2, and there's the answer that you were being asked to find. Good. Now, this one told you who x, y, and z were, right? So you could plug them in here. They could have done this. Only told you x is 2 and y is 2, right? Yet you'd still be able to do it. But you should be thinking, but I don't know z. Well, maybe you don't know it right now, but don't you know that x squared plus y squared plus z squared always equals 9? You see this there? So if you tell me x and y, can't I figure out who z is? And 4 add 4 is 8, so that makes z squared 1. I guess they probably should have put something like that, you know, just so that you don't pick the other one. So z is 1, and you just plug it in here, and boom, you get your answer. Suppose we have a point and there's a ship going this way and a ship going that way. And Z is the difference between the two ships. What would the connecting formula between X, Y, and Z be in this picture? How would you connect X, Y, and Z together?
That's easy, Pythagorean theorem.
Okay, so you say that, agreed? I would, and that's correct, and there's nothing wrong in that. I would just make it a little bit prettier and do that. Suppose I had, this guy is Y, and this guy is X, and this number here is 100, and I join these two guys together and I'll call them Z. Well, the connecting formula now is going to be a lot uglier and not so obvious. So let me show you how you would create a connecting formula. I would add in an invisible couple of dotted lines and make a big right angle triangle. And I'm going to use Pythagoras again. This distance would be him, so he's 100. This guy is still called Z. What is the distance from here to here?
X plus Y.
Are you all happy? That bit's Y, that bit's X. If you slide this over, X plus Y. Now the connecting formula then, isn't it going to be X plus Y squared plus 100 squared equals Z squared? Right, that's the connecting formula, right? Pythagoras, that guy squared plus that guy squared equals this one squared. You'd have to FOIL this out and get 2xy plus y squared plus, I don't know, 10,000 equals z squared. And then subtract a z squared and subtract the 10,000 squared. That would be the one that you then start differentiating with respect to x. So creating the connecting formula is the most important part. Without that line, you can't do anything. Okay, I think we probably get time for one last question. So who's got it?
You think we could go over those derivatives like as a function, like the f of a's and stuff like that, or find f of a?
I think you're talking about linear approximation. Is it the one where you think like a square root of x and a is 3 and you've been asked to find the linear approximation? Is it that kind of thing?
I was talking more about the stuff with or like you were having a self derivatives without the chain rule, like before the chain rule.
Can you think of a function, and I'll write it down, that would be kind of in that family, because I'm not quite sure where I'm right now.
Here, give me a second. I'm gonna go pull it up really quickly. I'm
Okay,
like right
that'll
there.
work.
You said the one you wrote above that was named linear approximation.
Yes. So what you would do here is find a thing called the linear approximation function. It would be f of a plus f dashed of a x minus a. What that basically does is it gives you a straight line formula that I'd probably make that 36, that you could use to approximate a square root function, as long as you pick numbers close to, in this case, say 36. I'm not sure if that's what he was talking about. That while he's
Oh, I mean, I can't find the exact one,
Okay.
but I just remember that we had to use. I want to say maybe it's something to do with like limits and stuff too, but can't exactly remember. I just know it was a very specific type of problem I was having trouble with.
well, when you come across it, you shoot me an email and I'll try and answer it that way. Since
Okay.
this one is set up, why don't we do this as our last one, right? Which is, how do you find the linear approximation function? Well, essentially you take your function, which is f of x, you rewrite it as a fractional power because you need to differentiate it. The derivative then is multiply by the power, reduce it by 1, and if you make that style points, you get that. The linear approximation function is f of a plus f dashed of a x take away a. So it's going to be the value of the function at 36 plus the value of the derivative at 36 times x minus a, which is 36. Right, the value at 36, well, the square root of 36 is 6. The derivative at 36 is 1 over 2 times square root of 36. 2 times 6 is a 12th. You can then distribute the 1/12 and then combine the numbers together. And this guy here is called the linear approximation function. So linear approximation function is 1/12 x, in this case plus 3. And now you can use it to estimate things that are close to 36. So if I wanted to, for instance, estimate what 36.3 is, then this would be the x I would use. So I'd get the linear approximation at 36.3, which is 1 over 12, 1/12 of 60.3, add 3, and then got my calculator and do 36.3 divided by 12, and then add 3, and I'd get the answer 6.025. And that would be my estimate for that, right? So you put little OC squiggly lines, that means approximately equal to. And now let's find out what it really is, see how good it is. The real answer to the square root be 36.6 is 6.049. Actually, if I round it off, it's 0.6.045. It's not a perfect fit, but would you also agree it's pretty good? Called the linear approximation function. It's a little niche thing, right? That's all it does. But it's kind of cool what it does. And if you wanted to know the error, wouldn't you just take one away from the other? And that's the error, right? How far off you were. In this case, 0.025. And it's time up, guys. So before you go, remind you all, our final is on Wednesday, the 16th, 9 till 12. So I'll see you all then. There are no more math classes. So I won't see you at all on Tuesday. I'll be taking finals for other courses then. And so I'll see you on Wednesday. Shoot me an email. I'll try and look as often as I can, but it's kind of busy time for me. So I may be a few hours late because I may not notice it or have time to see it till much later. Oh,
Okay,
When is this video
oh,
gonna be posted?
probably sometime later this evening, around about 7 o'clock would be my best guess.